Distributed control systems, or DCS, are like the nervous systems of big factories and plants. They control everything. DCS make sure things run smoothly and efficiently. Think of a power plant or a big factory making food. They need DCS to keep things running. DCS are important because they help us make things better, cheaper, and safer. They do this by automating processes and giving us lots of information. This helps us make smart decisions. Without DCS, factories would be much harder to run. Things could go wrong more easily. DCS makes sure everything works together in harmony. Field devices are the eyes and ears of a DCS. They are located out in the field, close to the action. These devices measure and control the physical processes happening in a plant. One type of field device is a sensor. Sensors are like our senses. They measure things like temperature, pressure, and flow rate. For example, a temperature sensor might measure the temperature of a furnace. Another type of field device is an actuator. Actuators are like our muscles. They control things like valves, motors, and pumps. For example, a valve actuator might open or close a valve to control the flow of liquid. Field devices are essential because they provide the DCS with real-time information about what's happening in the plant. This information is used to make decisions and control the process. Controllers are the brains of a DCS. They receive information from field devices and use it to make decisions about how to control the process. Think of them as the decision makers. There are two main types of controllers: programmable logic controllers, or PLCs, and process controllers. PLCs are used for discrete control, like turning a motor on or off. Process controllers are used for continuous control, like maintaining a specific temperature. Controllers use control algorithms to make decisions. These algorithms are like recipes. They tell the controller what to do based on the information it receives from the field devices. Section 4. Human-machine interface. The bridge between systems. The human-machine interface, or HMI, is how operators interact with the DCS. It's like the control panel for the entire system. HMIs use screens, buttons, and alarms to show what's happening. Operators use HMIs to monitor the process, change set points, and troubleshoot problems. They can see important information at a glance. For example, an operator might use an HMI to change the temperature set point for a reactor. HMIs are designed to be user-friendly, even for complex processes. They use graphics, trends, and alarms to make it easy to understand what's going on. Section 5. Communication networks connecting the dots. Communication networks are the backbone of a DCS. They allow all the different components to talk to each other. Think of them as the nervous system of the DCS. There are several types of communication networks used in DCS, including Ethernet, Profibus, and Fieldbus. Each network has its own strengths and weaknesses. Communication networks are essential for ensuring that information flows smoothly between the different components of a DCS. Without them, the system wouldn't be able to function. Section 6. Supervisory Control and Data Acquisition, or SCADA. SCADA systems are a type of industrial control system used to monitor and control large-scale processes. SCADA systems are often used in conjunction with DCS. SCADA systems collect data from field devices and display it on a central computer screen. They also allow operators to control the process remotely. SCADA systems are used in a wide variety of industries, including power generation, water treatment, and transportation. They are essential for ensuring the smooth operation of critical infrastructure. Section 7. The Symphony of Components in a DCS. A DCS is like an orchestra, with each component playing a vital role in ensuring the smooth operation of the entire system. They all have to work together. Field devices are the musicians, collecting data from the process. Controllers are the conductors, interpreting the data and making decisions. The HMI is the sheet music, providing operators with a clear view of the process. Communication networks are the instruments, carrying information between the different components. And SCADA systems are the audience, providing a high-level overview of the performance. Together, these components work in harmony to ensure that industrial processes run smoothly, efficiently, and safely.